Hi, I'm Tuukka Ahoniemi, an authorized Qt trainer from DIGIA. Welcome to this learning video based on material taken from Qt Essentials training course. With these videos, we're gonna give you key insights into Qt as well as demonstrate the style of the in-depth training given in the Qt Essentials training course, which are classroom-based. I'm going to be introducing you the QGraphicsView Architecture. This is something that's used for creating custom two-dimensional graphics. Let's start with a couple of examples on what is GraphicsView. The first one I'll open from an application called Examples and Demos. This application itself is implemented with QGraphicsView. You can actually get it with all the Qt installations, and it's basically a launcher for a huge amount of documented examples and demos. And on GraphicsView I have something called colliding mice here, which I want to share you. Let's launch it. Custom graphics. The whole user interface, if you like to call it a user interface, of this application is made using GraphicsView. So there's actually only one widget, which is the main window here, and that widget is a QGraphicsView. Okay, another example. I'll open the Qt Designer here with a project that has a UI layout that has push buttons, sliders, and then this white box here, which actually is also a graphics view. So on the left-hand side you have all the Q widgets which you could use for doing your UI layout, and one of them is the graphics view, which I've added here previously. So the layout in this application is normal Q widget based layout, but with some GraphicsView code I've added custom graphics in order to implement this game. So as you see, regular buttons and then custom graphics made inside a GraphicsView widget. The GraphicsView, one QGraphicsView is actually a widget, but it's a widget that is meant for showing custom two-dimensional graphical items that can actually have interaction with the user as well. So inside the GraphicsView widget, there's something called the GraphicsView Framework, which has its own set of classes. We're not using QWidgets there, but we're using QGraphicsItems and things derived from QGraphicsItems. Inside, it's using a model view controller paradigm. It's not dependent on any resolutions. You can do nice animations, rotations, scaling, transformations for those items inside. It's designed so that you could theoretically have tens of thousands of individual graphical items there, which would be fast discovered. You could do collision checking for them, because it's using something called binary space partitioning tree for fast recovery on the items inside. So this is something very useful if you're doing custom graphics for games, for instance. Let's start with the small Hello World application I will be coding here. So in Qt Creator, I created an empty Qt project which has a main window. It has a main application here, and I've created the Q application object. And like with any widgets, I could just create Q push button here, and it would become a window of its own. But instead of creating other Q widgets, I'm going to create a QGraphics view. So that view, that single view, will now become my main window. Okay, And of course I need to show it. Let's check. Okay, I had the previous one open. Let's check. Okay, there's one graphics view, but no contents. So let's create contents. And creating those contents requires something called QGraphicsScene. The scene acts as a model for the view. The scene is a container for those graphical items. I'll allocate the scene here dynamically, and I can create an empty scene, or I can give already an existing rectangle for the scene, an existing coordinate space. So let's do that. Let's say the coordinates of the scene will start from 0, 0, and it's going to be 300 times 300. And I can set a background brush for it, which for instance could be yellow. The scene is allocated dynamically, so I need to give a parent to it or delete manually. In this case I will give parent. I will have the view become its parent, but this does not yet mean that these two items would be hooked together, but I will explicitly need to tell view, by the way, the scene you are showing is this object here. Okay, let's try it. Oh, this is nice. Custom graphics, the yellow box. Okay, so now I have the scene with the background brush, but it's an empty scene. I don't actually have any graphical items there. So let's create some graphical items. I have two options in creating existing graphical items. I do have, for instance, text, pix map, rectangle, ellipse items in my use, or then I can create custom items. And for those existing classes, I can create an object, like I do here. Let's create a QGraphics rectangle item. And let's give a size to it, or actually a position. Let's say it starts from 50, 50, and it's 100 times 100 large. So now I can tell the scene that I want to add this item here. And the item will automatically be placed in the coordinates that I just gave it. Here. Other alternative is directly tell the scene that, hey, I want to add, for instance, a text item. Okay, let's say hello world, and let's check the output. All right. Right on. So let's look a bit closer on the different parts of this equation I had here. So I had the QGraphicsView, which is the widget. In this case, it was my whole main window. It didn't have a parent. That view is showing contents of one scene. I could have multiple views showing contents of the same scene, but in this case, and then normally you have just one view showing contents of one scene. And scene acts as a container for graphical items. In this case, the items which I had were the rectangle and the text. Let's start with scene. So the class is QGraphicsScene. You can use an existing QGraphicsScene. You can also derive your own class from QGraphicsScene if you want to create some sort of a custom functionality for it. But normally, using just plain QGraphicsScene is well enough. The responsibility for QGraphicsScene is just to act as a container for graphical items. It knows where are its items, it propagates events that are coming from the view to the correct items. You can ask from the scene that, hey, please do give me an item on these coordinates, and then you'll get the pointer if there's an item in those coordinates. Also, the scene is responsible for rendering the items into the view. So you can have multiple items on top of each other, and they have something called a Z value, which determines the order which is going to be placed on top of which. I showed you the add item, so you can have an existing item that you explicitly create an item object, and then you call add item for adding that to the scene, to those coordinates that you've set for the item. Also, for existing classes like text, rect, you can call these convenience functions of QGraphicsScene like add ellipse, add text, add rect, like I did in the previous example. From the scene, you can ask a list of items in certain coordinates with function items. You can ask a list of selected items, or you can ask the bounding rectangle for the entire scene. In this case, in my example, it was 300 times 300. But you can also create an empty scene and then have the items and their position determine the actual size of the scene. The scene will expand as the items are added, but it will actually never go back if you remove those items. Then we had the QGraphicsView, which is showing contents of one scene. So this is a scrollable widget viewport, which basically means that it's derived from QAbstract scroll area, and it will have scroll bars if the scene doesn't fit there. You can also set the scroll bar policy that you will never have scroll bars there. But it's a scroll area that's showing contents of a scene. That one is a widget, so you can put it inside layout managers. It will get events delivered the same way as other Q widgets, but it will then propagate those onwards to the scene, who will take control on propagating that onwards to the individual items. Some methods for view, for instance, SetScene is something you quite easily forget. You just don't have your scene showing anything. So you will always need to tell the view what is the scene which it will be showing. You can call setRenderHints for doing optimizations for drawing, like anti-aliasing. You can center the view to certain coordinates, like what is the place of the scene that is showing. You can also map from different coordinate systems. All of these three actually have their own coordinate systems. So you can use conversion functions between these coordinates if you want to access them manually. And then what's nice is that you can actually do transformations for the scene itself. Like if you want to rotate the whole world, your scene will remain still, and then you will just have the view rotating around. Or if you want to do tuning, you'll just basically call scale for the view. The scene stays still, the items stay still. The view is the one who can be transformed. Finally, we have the item. Like in the colliding mice example, we had those 7 mice there. There's 7 objects of class mouse. The mouse is derived from QGraphicsItem. So in that case, it's a custom QGraphicsItem. So you can derive your own class from QGraphicsItem and do your custom graphical items that way. But if you do not need everything made customly, you can just use the existing classes like rect item or text item, which I had in my Hello World example. You can also do transformations for the items, like the mice themselves were rotating and moving on the scene. You can do drag and drop for widgets, similarly than for the widgets for items. And you can get the position in its parent's coordinates. The majority of the functions for the item work in the item's own coordinate system. It will have it, like for instance, drawing. Every time the mouse draws itself, regardless of its position, it will draw itself the very second way. But the mouse also knows its position in its parent's coordinates. And in this case, the parent is the C. So with function pos, you can get the position in the C. And then you can call set pos, or you can call move by, in order to move the item in the C. Items can be also hidden with hide function and then shown again. You can enable and disable them. You can set focus for them. After it's gotten focus, it can receive keyboard input, for instance. You can set different flags for graphics items, for instance, whether it can have the focus or not. If you want to have keyboard focus for an item, you need to call set flags so that it will receive focus if it's clicked, for instance. You can do groups out of items. In the previous example, in the colliding mice example, the parent of each mouse was the scene. So they were moving in relation to the scene's coordinates. But you can also set another item to be a parent of some graphics item. In this case, they are grouped. And if you enable or disable the parent, or you will move the parent, all its children will be moved along. So this allows you to do like compound graphical items from existing objects. We hope you enjoyed this taster of our Qt Essentials training course. For the full interactive experience, including labs, questions and answers, additional info, I personally recommend you attend the full multi-day training Qt Essentials provided by DIGIA or any of the other Qt training partners. For more information, please check qt.nokia.com. Thanks for watching.